Chapter 5: Sensation and Perception. Today, we turn to an essential question in psychology: how do we experience the world? Everything we know about our surroundings, every sight, sound, smell, taste, and touch, comes through the process of sensation and perception. Sensation is the process by which our sensory organs detect physical energy from the environment. Perception is the process by which the brain organizes and interprets those signals, turning raw data into meaningful experiences. Sensation gives us the pieces. Perception puts the puzzle together. This chapter will guide us through the difference between sensation and perception, how each of our senses works, and how the brain integrates this information into coherent awareness. 5.1 Sensation versus Perception. Let's begin with the distinction. Imagine you are sitting in a cafe. Your eyes detect light waves reflecting off a cup. That's sensation. Your brain interprets the pattern of light as a coffee cup. That's perception. Sensation is biological. Perception is psychological. Sensation is about receiving input. Perception is about making sense of input. This process is not flawless. For example, sensory thresholds determine what we can detect. The absolute threshold is the minimum amount of stimulation needed to notice something, such as the faintest sound or dimmest light. The difference threshold, or just noticeable difference, is the smallest change we can detect. For instance, noticing when music gets slightly louder. Our sensory systems are also influenced by signal detection. Whether we notice a stimulus depends not just on its strength, but also on our expectations, motivation, and attention. This explains why a mother can hear her baby cry at night while sleeping through louder sounds. Finally, perception is shaped by top-down processes, our experiences, knowledge, and expectations, as well as bottom-up processes, raw sensory data. This is why two people can look at the same ambiguous picture and see entirely different things. 5.2 Vision. Of all the senses, vision is perhaps the most studied. Light waves enter the eye through the cornea and pass through the pupil, whose size is controlled by the iris. The lens focuses light onto the retina at the back of the eye. The retina contains photoreceptor cells, rods, sensitive to low light, important for night vision, cones, sensitive to color and detail, concentrated in the fovea. The optic nerve carries this information to the brain, where it is processed first in the thalamus and then in the visual cortex of the occipital lobe. Color vision is explained by two theories. The trichromatic theory proposes that cones are sensitive to three wavelengths, red, green, and blue, and all colors are combinations of these. The opponent process theory explains after images, suggesting we have pairs of opposing colors, red, green, blue, yellow, black, white. Vision is also shaped by perceptual principles. Gestalt psychologists emphasize that we perceive wholes, not just parts. Closure, figure ground, proximity, and similarity all help us make sense of visual input. Depth perception, studied famously with the visual cliff experiment, shows that even infants can perceive depth cues. 5.3 Hearing next is audition, or hearing. Sound waves are collected by the outer ear, amplified by the middle ear, and converted to neural signals in the inner ear. In the cochlea, tiny hair cells on the basilar membrane bend in response to sound waves, triggering action potentials. Different parts of the basilar membrane respond to different frequencies, allowing us to hear pitch. The auditory nerve carries signals to the brain, where they are processed in the temporal lobe's auditory cortex. Two main theories explain how we perceive pitch. The place theory says pitch depends on which part of the basilar membrane vibrates. The frequency theory suggests that pitch is linked to the rate of neural firing. Both work together to explain our wide range of hearing. 5.4 Other senses. Beyond vision and hearing, we have several other critical senses. Smell, olfaction. Chemical molecules in the air bind to receptors in the nasal cavity, sending signals directly to the olfactory bulb, which has close connections to the limbic system. This explains why smells are so strongly linked to memory and emotion. Taste, gustation. Taste buds on the tongue detect 5 main tastes: sweet, salty, sour, bitter, and umami, savory. Taste is influenced by smell, texture, and even expectation. Touch, somatosensation. The skin contains receptors for pressure, vibration, temperature, and pain. Pain perception is complex, influenced by both biological signals and psychological factors like attention and mood. Vestibular sense. Located in the inner ear, this sense detects balance and spatial orientation, allowing us to walk, stand, and move smoothly. Proprioception. This is the sense of body position, our awareness of where our limbs are without looking at them. Together, these senses provide a rich, multisensory experience of the world. 5.5 Perception and the brain. Finally, perception is not simply a passive recording of the world, it is an active construction. Our brains interpret and sometimes even alter sensory information. Perceptual constancies help us maintain stable perceptions despite changes. For example, we see a door as rectangular even when viewed from an angle. Context also plays a powerful role. What we expect to see or hear often shapes what we actually perceive. Illusions highlight this active role of perception. The Muller-Lyer illusion, for instance, tricks us into perceiving two lines of equal length as different. Such illusions reveal the shortcuts and assumptions the brain uses to interpret the world. Closing thoughts. Sensation and perception remind us that reality is filtered. We do not experience the world directly. Instead, our senses gather raw data, and our brains construct a version of reality based on that data and our past experiences. This constructed reality is usually accurate enough to keep us alive and thriving, but it is not perfect. By studying sensation and perception, psychologists uncover how the biological and the psychological interact, how photons become vision, how vibrations become sound, and how chemical molecules become memories of a childhood meal. This chapter reminds us that what we see is not simply what is out there, it is what our minds allow us to perceive. The world we experience is always, in some sense, a creation of the brain.